In this video, we're going to look at learning outcome number 2 from section 1.1, which is outlining how to conduct a statistical study. So this is the outline from the Triola textbook. I'm not going to read it to you, but I will say that the big picture is this. When we're talking about conducting a statistical study using statistical and critical thinking, basically we need to prepare. So we need to prepare to analyze some data. And then we're going to analyze that data using appropriate statistical methods. And then we're going to come to some conclusion. And that conclusion might have something to do with statistical significance, or it might have something to do with practical significance. So here's the first part. We're going to prepare to conduct a study. That's going to include 3 parts. First, we're going to consider the context. When we have these numbers, and usually that's what it is, it's lists of numbers, like you see in an Excel spreadsheet, and you've got a couple of rows or a couple of columns. The question is, well, what do those numbers represent? Are they parking spaces? Are they someone's weight and somebody's height? Is it, male or female? Like what exactly do these data represent? Is it a social security number, or is it an amount in someone's bank account? Like those are 2 different things. So we want to consider the context in terms of what the data represent. And then we want to consider what the goal of the study is. Then we want to consider the source. We want to know, is this source reputable? Can we trust this source? Do they have a good reputation? Or does the source have some incentive to produce biased results? Are you reading a study about tobacco from someone who's trying to sell you tobacco? Are you reading the results of a study about higher education from somebody who has incentive to say something positive about higher education? Or are you reading the results of a study from someone who's trying to sell you something? All of those are incentives to produce bias potentially. So you want to consider the source and consider what the goals of the study are, and if they have some, I can't think of the word, if they have something to gain from falsifying data or being biased in their presentation of data. And lastly, we want to consider the sampling method. If we understand the context of the data, and even if that source is reputable, if we're not sampling in the right way, we can learn something about the sample. Probably using statistical methods, but it doesn't really apply to the original population. So we can say something about that small subset. We can say something about, let's say, those like 30 carbon monoxide detectors in the last video, but we can't say something about the 38 million if we haven't sampled correctly. So we want to know, are those data likely to represent the entire population? And were they collected in an unbiased way? So let's go through these steps. So we're preparing to conduct a statistical study, and this is our data set. Now, if we didn't have this column that has the names here, if I just had this list of numbers on the right, it really wouldn't mean anything to me. So the first thing I need to do is consider the context. These are pleasure boats and manatee fatalities from boat encounters. And the first thing to do is consider context. This is the number of registered pleasure boats in Florida in tens of thousands, and the number of manatee fatalities from encounters with the boats in Florida for each of several recent years. So these are in tens of thousands. So this is 990 1,000 pleasure boats, and during that particular year there were 92 manatee fatalities. Now the following year, or what appears to be the following year, in another year, there were 990,000 pleasure boats approximately, and there were only 73 manatee fatalities. But we've got all of these pleasure boats, these total numbers of pleasure boats in Florida in a particular year, and we have the manatee fatalities in that year. So we want to think about what the numbers that were given represent, and we have. And now we also want to think, like, okay, given this information, like, what are they trying to get at? What are we trying to find? Well, when I see this, I think, well, someone is trying to see if there's a relationship between these two. So This would imply that the goal of this study is to determine whether there's a relationship between the number of boats and the number of manatee deaths from boats. Saying, if the number of boats goes up, does the number of manatee deaths go up? If so, and how accurate can we expect that, or how much can we trust that relationship? And we'll look at how we decide that later this semester. Then we want to consider the source of the data. We say, who gave us this information? This is from the Florida Department of Highway Safety and Motor Vehicles, okay, and also the Florida Marine Research Institute. So these guys are very likely to want to be honest with us. I would trust this data. They're both reputable sources. I don't think they would have any incentive or reason to lie to us. And then we also want to consider the sampling method. And it says, from official government records known to be reliable. Well, if we know them to be reliable, then we can trust them. So that is preparing to conduct a study by considering the context, the source of the data, and the sampling method itself. Now, you want to be careful about what are called voluntary response samples. This is another important term, an essential term that you should learn before the end of the semester, and hopefully you learn it right now this week. A voluntary response sample, or a self-selected sample, is one in which the respondents themselves decide whether to be included. So here are some examples. Internet polls. If someone says, oh, how do you feel about this? And it just sort of pops up, and then you answer yes or no. I've seen a lot recently about like our next president. Do you favor the current president or not? Do you not favor, do you favor his opponent or not? And that'll just pop up. You could participate in that poll, but that's a voluntary response sample. A lot of people see that and ignore it. So while you might be able to come to some conclusions about the people who chose to participate in an internet poll, it's not necessarily representative of how the entire population feels about either of those two candidates or about whatever it is that they're polling you about. Mail-in polls are the same thing. If they send you something to your house and then they ask you to participate in a poll, the results of that poll only tell you about the people that were polled. They don't tell you about everyone. And the same thing is true with telephone call-in polls, newspapers, radios, stations, and television announcements sometimes will ask you to call and share your opinion. Well, people that call and share their opinion are likely to be different from the people that choose not to call and share their opinion. So those are all voluntary response samples, which mean that the results of those polls don't tell you anything about the population. They can be very large samples. Lots of people can participate, and it would tell you nothing. Okay, so here is an example. It says, Nightline asked viewers to call with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of 186,000 respondents said that the UN should be moved out of the United States. So if I asked you now, well, how many people, or what percentage of people in the United States believe that the UN should be moved out of the United States? Well, if you weren't thinking about statistics, you might think, well, based on that poll, at least 67%, that sounds reasonable. And we want to be careful about that. We don't want to anchor to that and think that it's got to be close to 67%, because we have to consider that context again. So that's one poll. In a separate independent survey, 500 respondents were randomly selected and surveyed, and only 38% of that group said that they wanted the UN to move out of the United States. So you've got a 500 respondent group, and only 38% want to move the UN out. And then you've got this 186,000 respondent group, and 67% wanted to move the UN out. And you might say, oh, is it 68%, or is it 67%, or is it 38%? Like, what is the difference between these two numbers? Why? Why this gross difference? And which numbers can I trust? Well, let's think about it. I just get really excited with all my PowerPoint animations. Sorry about that. Well, not sorry about that. I like those. In the Nightline poll, we had 186,000 volunteer respondents. In the smaller poll, there were 500 randomly selected respondents. Even though you would tend to think that having more respondents is better, we really need to consider how those respondents were chosen from that larger population. So if I've got volunteer respondents, it doesn't really matter that there were 186,000 of them. It's not going to be accurate. It's not going to be trustworthy, because there's something about someone who chooses to volunteer that is just different from someone who doesn't choose to volunteer. So we should really throw out the Nightline poll. It doesn't really tell us anything. Now that smaller poll, it had 500 respondents, but the respondents were randomly selected. Since they were randomly selected, just by nature of being randomly selected, that data is much more trustworthy. So this is much more likely, the second poll is much more likely to be representative because of the far superior sampling method, and that's that random selection. We're going to talk more about that very shortly. Next, we want to analyze our data. So typically we do this by graphing the data and exploring the data, and we're going to get into that in the next couple of chapters. So we should begin by creating appropriate graphs and exploring the data. When you have lists of numbers, it really doesn't tell you much. But when you start creating what are called frequency distributions and histograms, and you start looking at measures of center and measures of variation, and those are all words we're going to get into later this semester. When you do all of that, that list of numbers, which almost seems meaningless, starts to tell you something. It starts to make more sense. So we're going to create data, or not create data, never create data. We're going to create graphs with data, and we're going to explore that data as the beginning step in analyzing the data from our sample. And then we're going to apply appropriate statistical methods. Now, I will say, and this is something that the author of our textbook analyzes a lot, this class is not about computation. It's really not about fluency with algebra. You don't even have to be that great at arithmetic. You really just need to know how to put your expressions in the right parentheses into your calculator and get an answer out that makes sense. This class is not about algebra, and there's not a lot of computation involved. But it is going to require that you understand statistical methods, when they apply, what these numbers mean. It's going to require using a lot of common sense. And that's what we're going to emphasize. We are going to do a little bit of computation in this class because it's important that the Excel spreadsheet or the TI-84 or 83 calculator or SPSS or any of those things, it's important that they're not black boxes. It's important that we have some sense of what it is they're doing and why they're doing it. But once we understand that, it's silly. It's really silly to try to do all of that computation by hand. If you're finding, let's just say, the mean of some data set, so you add all of the numbers together and then you divide by the total number of elements. It's really silly to just practice adding those numbers together and then dividing when a calculator can do it for you, or an Excel spreadsheet can do it really easily. My thought is that if you understand the math well enough to type it into Excel and get Excel to type that formula or produce that output for you, then you truly understand the method. If you can tell the computer what to do and then the computer does it correctly and you get the right result, then you understand the math. So this is really not about computation or algebraic manipulation. It's just about understanding what methods apply, understanding what they say here, sound statistical methods, and paying attention to details, and then using your common sense. So I hope that makes you feel better if you're not, you don't think of yourself as a math person. And then lastly, we want to conclude whether the results are statistically significant or practically significant. It's kind of hard to remember what it was we were doing, but let's go back a little bit. So we're right here. We want to prepare for our study. We want to analyze data. And then once we've prepared for our study and we've analyzed the data, we want to come to some conclusion about the original population. Oh, screen sharing has closed. Sorry about that. Let's do it again. There we go. We want to come to some conclusion about the population. Let's go to the appropriate slide. Okay. Our goal is to conclude whether results are statistically significant or practically significant. Now, when we talk about whether something is statistically significant or not, that's going to vary based on a number. We'll get into that more later. There's going to be some way that we can measure that, and we're going to measure it better later in the semester. But here is Triola's definition. Triola says that statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So what that's saying is, if it's very unlikely, if it's only likely to have occurred by chance like 4% of the time or 2% of the time or 5% of the time, then we're going to say that's pretty unlikely. That's statistically significant. Otherwise, we're going to say it's not. So here's an example. Let's say you had 100 random births and you got 98 girls somehow. Well, normally, it's either a girl or a boy after birth. If you have 98 girls out of 100 random births, and we think typically it's close to 50-50 as far as getting a boy versus getting a girl, it's very statistically significant that there are 98 out of 100 random births that happen to be girls. Something happened. Why? How did we get all these girls? It's a very extreme outcome, and it's not likely to result from random chance. But if we got 52 girls out of 100 births, and we're expecting on average about 50% to be girls and 50% to be boys at birth, well, that's not statistically significant. Because if we're expecting about 50% and we get 52%, we're saying, I really don't know. It's probably not statistically significant. It could easily occur just by random chance. You pick a different 100 births and maybe there'd be 48 girls, a different 100 births and maybe there'd be 53, like who knows? But if it's all around 50, that sounds sort of normal. If it's not around 50, it's not normal. And when we think of something as not being normal, we think of that as statistically significant. If it's sort of typical, that's not statistically significant. Okay, and now we also want to examine what is called practical significance. And statistical significance and practical significance, these are two different things. And this actually has a definition in our course. So here's the definition. If it's possible, or it is possible, that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So what is that saying? So it's possible that there is some statistical significance, some measurable difference between applying the treatment and not applying the treatment. But if that effect size is small, if it's tiny, if applying that treatment only led to a tiny, tiny, tiny difference in that potential outcome, you might say, well, it works and technically it's statistically significant, but would I really want to spend all the time and energy investing in this treatment if the difference is so small? Well, then we would say it's statistically significant, but it lacks practical significance. Practical significance is when the treatment does seem to make a difference, enough of a difference to be useful or practical, whether it's statistically significant or not. So here's an example, and we're given some context. I'll read it to you. It says, ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender they desired. In the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. Okay, so FDA banned it because it was deceptive, and let's see why. The product was tested, with 10,000 couples who all wanted to have baby girls. And the result consisted of 5,200 baby girls born out of the 10,000 births. Now, this result is statistically significant because the likelihood of that being 5,200 out of the 10,000, the likelihood of that happening by chance was only 0.003%. So it's very unlikely to happen by chance. So chance does not seem to be a feasible explanation, but look at the percentage. You've got 5,200 out of 10,000. So it's like a 52% chance of getting a girl using this method. So we've got a 52% rate of having a girl. It's statistically significant because of the sample size, but it lacks practical significance because if you are a couple and you're trying to have a baby, 50% versus 52%, it really is not a big enough difference to make you want to spend your money on it. Now, that company could have said, we have evidence, we've conducted a study and we have statistical proof or statistical support for saying that this treatment actually helps, and they wouldn't be lying. But the practical significance is so small that the FDA said, we're not buying it, you're not actually thinking about your customers and what they want. So statistical significance, while important, is not enough to justify the use of this treatment. Most couples would not want to spend time and money to increase the likelihood of having a girl from 50% to 52%. If they're going to have 100 babies, that might work. You know, you have 52 girls instead of 50 girls, but if they're only going to have a few kids, going from 50 to 52% isn't that big of a difference. And here's just a note from the author. He says, in reality, the likelihood of a baby being a girl is about 48.8% and not 50%. But we know it's about 50%. Okay, so that is the end of that particular learning outcome. Excuse me, sorry about this. So that's the end of that learning outcome. And that was about outlining how to conduct a statistical study. So let's look at it again. Share my screen with you again. So basically, we want to prepare for our study. When we prepare for our study, we want to consider the context. What do these numbers represent? What's the goal of the study? What's the source of the data? Can we trust them? Are they likely to be biased for one reason or another? And was the sampling method a sound sampling method? Are the results likely to be biased? If it's a voluntary response sample, we don't want to trust that data. It doesn't say anything about the population, although it can say something about the sample who decided to participate. So we do that first. We consider context, source, and sampling method. Then we analyze our data. So we're going to take all these numbers typically, and sometimes we have qualitative data, but for the most part, you're just sort of sorting things. And then based on your sorting, you're graphing. And then we're going to explore the data. So we're going to think about things like outliers. What are the important statistics that summarize that data? We're going to talk about the mean, which is a measure of center of data. We'll talk about what that means soon. We're going to talk about standard deviation. That's how much that data is varying. We'll talk about that soon as well in chapter 3. And we want to know, how are the data distributed? Is, all the data pretty much centered on a single point? Are they all very, very close to the mean, or is it more spread out? Is there some missing data? where there's some subjects that decided not to respond. So we want to take all of that into consideration. And then we want to apply appropriate statistical methods. And usually we're going to use technology to obtain the results. We're going to do a little bit by hand, and then once we do a little bit by hand, we're going to use things like Excel to calculate the results that we're looking for. So we prepared our study, we analyzed our data, and then we have to look at those numbers and then think about two things. Is it statistically significant? So are the results very unlikely to have happened by chance? If they are unlikely to have happened by chance, it's significant. If it's not likely or not unlikely to have happened by chance, it's not significant. And then we have to think about practical significance. So when you think about people, you say, well, is this meaningful for the people on the other side of this study? So that is our outline of what it's like to conduct a statistical study. And that's a lot of what we'll be doing and discussing throughout the rest of the semester.